Hi, my name's Alan Kim. I'm a second-year PhD student here at the Johns Hopkins Bloomberg School of Public Health, and I'm happy to say that I'm a 2023-24 recipient of the IFER's Graduate Student Fellowship. The fellowship really helped me decide that this doctoral program was the best option for me, and it really helped provide me the support that I needed to continue my education. So thank you for your contributions, because they've really directly helped gone to supporting my research and the work I continue to do here. So with that, I'm very proud to show you the research that I've been able to complete and that I plan to do with the support that you've helped provide me. As a general background, over the last several decades, the incidence of several neurodevelopmental conditions such as autism, ADHD, and schizophrenia have increased over time. While we're not entirely sure what's driving these changes, a prevailing theory is that exposure to environmental chemicals is at least in part responsible for this increase in incidence over time. As such, many governmental agencies already have their own in-house assays and tests that they use to screen chemical compounds for potential developmental neurotoxicity. However, these models are almost entirely based on animals, and as such, they can take upwards of thousands of rat or mice pups, millions of dollars, and several months of time, all to screen one chemical compound for potential developmental neurotoxicity. However, we have a backlog of tens of thousands of chemicals that haven't yet been tested for these endpoints, and as such, the current paradigm of using animal models to fix this issue is just not going to work. Now, in order to provide a viable replacement for these animal models, we've proposed to use a human stem cell-based model in order to make a replacement for those animal tests. Thankfully, the group I work with, the Center for Alternatives to Animal Testing, already has their own in-house 3D human-based brain organoid model that would be a great replacement for these animal tests. We use donated human cells, which are then reverted into stem cells, and then are differentiated into progenitor cells, and then allowed to aggregate together before differentiating into various neurons and other cell types of the brain. This allows our model to not only be three-dimensional, but it also recapitulates a lot of the complex cell-to-cell interactions that are occurring in a normal human brain. My project involves inserting a fluorescence tag into these stem cells so that when they further grow into neurons, they'll light up or literally fluoresce under a microscope and allow us to track neurodevelopment over time. We can literally see these neurons grow and change over time, and we can see how different those neurons look when we have exposure to certain environmental chemicals. If validated, our model could provide regulatory agencies with the tools that they need to screen chemical compounds for developmental neurotoxicity. We are providing them a robust, reliable, and affordable model that they can use to screen thousands of chemicals for these compounds in a reasonable amount of time. As such, we can finally remove this backlog of tens of thousands of chemicals and finally find out more about what potentially developmentally neurotoxic compounds are in our bodies and in the environment. I think that it's important for scientists to embrace these new technologies and to commit to the idea of replacing animals in experimentation. Thank you so much for your support. I'm excited to show you what I'm able to do in the future. Thank you.